Hi everyone, this is Dr. Vittle, and I know that many of you have worked really hard on homework assignment 1 and faced many challenges, I'm sure. This is the first of several videos that I'll be showing about how to actually do things in the upcoming programming assignments. So now that everybody has gotten through the preliminaries, I'm pretty confident that we'll be able to make some progress. Oops, let me stop. Okay, this is Dr. Vittle. I wanted to take a little bit of time to introduce Homework 2B, which is going to be adding on to the ideas of Homework 1. As you probably all know, in Homework 1, the goal was to learn the basics of building a task graph and doing whatever you can to figure out how to execute it. In the next significant programming assignment, which is Homework 2B, we're going to be actually taking a look at how to generalize the task model so that we can support any kind of interesting data flow computation. You might actually want to know a bit more about data flow. Basically, way back in the 1960s and 70s, there was a class of data flow machines that were created, which were designed to support a novel idea at the time, which is how to take data and use it to direct computation. If you think about how computing works today, we still are using what's called the von Neumann style of computation, where the instructions fetch the data and then perform some operation. In data flow, things work kind of backwards. The data come to the instructions, and an operation is performed, and then some data can be sent to elsewhere in the task graph. If you look at Homework 2B, you'll see that I have set up a task graph, and just to make sure we understand what's going on here, there are the task labels, which you probably recognize from Homework 1. And the one thing we're doing differently in Homework 2 is we're going to take and we're going to map these tasks to what we call user-defined behaviors. So this actually also shows kind of a typical type of data flow computation. I want to point out that this is what we call static data flow. That is, the tasks are all known in advance, and there is a more sophisticated type of data flow that we might work towards, subject to interest, which basically is where we would, actually take these tasks and we would be able to even generate task names at runtime. We'd be able to have reentrant tasks and so on. In our system, the tasks run, they complete, and they never run again. So for example, T1 runs. When it finishes, it is not going to run again. And the reason I made this decision is so that we could actually have an assignment that could be completed in our lifetime. Okay, so anyway, what I've done for you is I've actually taken and shown you what the task graph looks like, and it also shows how the wiring is done. So for example, task 1, which is mapped to get A, returns a message, which then becomes the left input of task T3. Okay, and task 2 is generating a right message, which becomes the input of task T3. So what we're doing here is we're actually seeding the data flow computation with some values. Let's take a look at get A, and it'll kind of shed some insight into what's going on here. I had to handwrite this, and then what I was trying to do is to actually show you just some pseudocode for how you understand what these different methods in my homework assignment would be written. So the get A task is basically what will happen when T1 runs. It has a message, which is going to be generated. Message is a type that actually is defined in my JHPC library, which you actually did get some brief exposure to if you looked at the date client and date server code. So you may want to use this message type, or you can create your own message type which has key value pairs. In my message system, which I will be introducing in a separate video, it has the ability to set key value pairs that are typed. So for example, I can create a key named value which has an integer value associated with it. This way, when I try to get the integer in another method, which comes down in the add method, I will be able to do something with that value and actually perform an operation without having to perform all these conversions and from to and from the string data type. So that's basically why we have a message type. Anyway, so we unpack the message. That's how you should think of this. Not unpack the message, but what we're doing is we're actually taking this message, we're putting a value 25 in it. The get B message is actually doing exactly the same thing as get A, but it is setting the value equal to 30. Now I want to point out this is kind of overkill for doing this computation, but keep in mind that more interesting data flow computations could even perhaps take their input from a data file or something like that. So keep in mind it's intentionally simple so we learn the basic principles of what a data flow system does. The add method is basically going to consume these left and right messages. And what I mean by this is that you will take and actually, so let's actually go ahead and even take a look at what the add message does in our code. So for example, we would create message add, right? And then we have this incoming map of messages. Now you might wonder, why do I have a map of messages? And the answer is that we need to be able to identify which input is being handled. So take a look at the add method here. You'll see that there are left and right messages coming in. So by having a map, and by the way, I do apologize, there's a bit of a typo here. It should actually be, let me fix that. And I'll fix it in the assignment as well. This should actually be, for all the methods, should be map string message, because this corresponds to, so let's fix that right now. Map, it's a string, string. Let's try this again. I'm getting used to this new software. So I hope everybody will please indulge me as I try to become a master of so-called online lecturing. Okay, let's try this again now. So now this will allow us to actually perform that get. The code is correct in my example on, let me see if I can, what did I do? Okay, I think I'm going to have to do this on a new page. Let me try that. Okay, well, let me just try doing it here. So anyway, for now, so if you take a look, you'll see that if you look at the actual assignment description, you'll see that there is a message. And I just bind this to a local variable here. Left equals incoming. For the purpose of not having to write the word incoming over again, I'm going to ask everyone just to let me type the word in here. In fact, in my own previous work on data flow, I always used in as the way of talking about the input values that are coming in. So in dot get, and we're going to get the left operand, or the left value that came. Now what is that left value? It is actually going to be the message that got returned by A. So basically this is going to become the left message of what? Well, add in our original graph is T3. Okay, so basically it is T3. Okay, we don't actually in the implementation of this getA method, we remain oblivious to where this actual message is going to. It is the job of the person who wrote the task graph to indicate the wiring. Now what's nice about this is that if we wanted to actually reuse the add method to perform a more complicated expression, we could do so without having to actually change the code of the add method. In fact, I'm going to talk about that probably a little bit later because I'm already at 10 minutes into this video. Okay, so we do this similar for write. Okay, that looks almost like the word night, but anyway, it's write. Okay, and then what we're going to do is we're going to take, now by the way, we could have actually just done this, by doing it all in what's called a fluent style, where we could even have a dot, get int param here. But that's a little hard for me to write on the display right now. So anyway, let's go back to blue here. Okay, so similar for write. So basically, if you look, there is a calculation being performed, which is result, which is an integer. I should declare that. Let's put that here. Equals, we're going to say left get int param value. All right, plus write similar. Okay, and then we will create a message similar to what we did in the getA that has this result and send it off. There's a little bit of a problem for me to write all that here, but I'll do it over here. So basically, message result equals new message. And then we're going to say result. Oops, what did I do? I have an integer result. I probably should give a different name to the message. Let's just call this, yeah, I have a little bit of a typo in my assignment as well. But anyway, let's just call this R. I'm going to erase this here. R. Let's fix this now. So R, and then R.set int param, and I believe that in my description I used the same name, the same key name for this, so value, comma, result. And then all we do is we return that message. So this will then go off to the final task, which is called print results. And print results is a very simple method that just grabs the message that was produced and it will actually print it out. So that's basically my first attempt to use this. This software I'm using here is called Vittle, which is running on the iPad. And I'm going to become more of a master of it, but I wanted to get this out right away and show you what the ideas are of Homework 2B. I think you're going to find that Homework 2B is a really, really fun assignment, and it will actually, I think, change the way you think about computation. That's why I find it to be so much fun. Just as a side note I want to make as a general point is that we could make this message type very sophisticated. So right now, we're doing things like integers here, which is not the best use of data flow because, data flow does have a little bit of, overhead, as you can see here. But if we were talking about like array types or some kind of larger object types, which is what happens in data processing in general, we could potentially do some, more complicated data flow computations. So right now, I want you to be understanding that this is kind of intentionally simple, but I have some more ambitious plans for it later in the semester. And of course, you can also explore this in class projects. So anyway, my parting thought is to have fun.